MERS is a coronavirus, so it's a respiratory virus, and it causes a respiratory infection. You get it by inhaling the virus particles. And so the problem with it, and the scary part about it, is that it is a respiratory virus. So you get it by close contact with individuals who are infected. And if you are around anyone who is infected, who is actively coughing and showing symptoms, then your your probability of infection dramatically increases. MERS is very lethal. Around 40% of the cases of people that have been infected with MERS have died from the virus. Many of those cases have been sick with something else before they got MERS, but even with those other illnesses, the percentage of death from MERS at 40% is incredibly high. This type of outbreak can continually happen until MERS is contained in its source, which right now is Saudi Arabia. So were 2 cases in the United States 2 years ago where people had flown from Saudi Arabia in the Middle East to the United States and brought the virus with them, and they weren't diagnosed with MERS until they entered the United States and got sick. In those cases, there was no spread between those individuals and healthcare workers or anyone around them, and we were lucky. So we have 4 different therapeutics we're working on in the lab. The first is the use of old drugs that are in the US that are already FDA approved for other diseases, testing whether they work against both SARS and MERS. The second is a novel vaccine against MERS that seems to be working very well in the lab. The third is a human antibody that has been produced in the lab that also works incredibly well and seems to be very potent. And the fourth is another human antibody from a different company that is able to inhibit MERS in the lab. We do think that this work could actually very quickly be translated into clinical cases and clinical usage. I think that more than any other thing we're doing in the lab right now, the drug work is the fastest way to get from the bench to the bedside.